differentiating sine inverse x or any of the other inverse trig functions requires the use of implicit differentiation. So we start off by saying let y be equal to sine inverse x, where y falls in the range negative pi over 2 to pi over 2. That is how the sine inverse function is defined. Now we're going to take the sine of both sides in order to get rid of the inverse trig. So sine y is equal to x, and then we're going to differentiate implicitly, meaning we're going to differentiate each side with respect to x. So we're going to take the left and differentiate it. We're going to do the same thing to the right. When you differentiate sine y with respect to x, you're going to get cos y times dy dx. Right, that's your implicit differentiation. Equals, when you differentiate x now, you get 1. Go ahead and make dy dx the subject. Now we're not going to end here. We want our result to be in terms of the sine y, right? So that we can connect it to x, because we want our answer to contain x's. So we need to find a relationship between the cos y and the sine y, which is x, right? So we need a relationship that connects cos y with sine y. And of course, we have that Pythagoras theorem that says cos squared y plus sine squared y is equal to 1. And if I transpose, I get cos y is equal to have 1 minus sine squared y, and then we take the square root. Now I'm only taking the positive square root because of where the y is defined, right? Y is in, this would be quadrants 1 and 4, and cos is positive in quadrants 1 and 4. So we know we're going to get the positive square root. All right. So cos y then is equal to the square root of 1 minus, and remember we connected it to sine y in order to use this value here, or this variable here, x. So 1 minus sine squared y would be 1 minus x squared, because the x is sine y. So 1 minus x squared, right? Can go back to my dy dx. Therefore, dy dx is equal to 1 over, remember it's 1 over cos y, and this is cos y. So 1 over the square root of 1 minus x squared. And that's the derivative for sine inverse of x. You can even add that to your table. Oops. I should be taking the derivative of sine inverse x. The derivative of sine inverse x is 1 over the square root of 1 minus x squared. Alright, and that's a result you should know. Now we can use this to, suppose we want to generalize. This one was specifically for sine inverse x. But suppose we want to generalize. Suppose we want the derivative of sine inverse of some function of x, right? So not x, but f of x, some function of x. Well, then this is where the chain rule would come in. We would use this, right? We know it's going to be 1 over the square root of 1 minus, now what we have here in this one is an x, which is why we get x squared. But what we have in this one is f of x, so we need to get f of x squared, right? So f of x squared times, because remember we're using the chain rule now, we know. So we treat this like it were just an x initially. So we differentiate it as if it were just an x. So 1 over the square root of 1 minus f of x squared, matching up with this. But then we have to remember to times by differentiating the f of x. So we would differentiate and get f prime x. If you differentiate f of x, you get f prime x, which means the derivative of sine inverse f of x is equal, if I simplify, to f prime x over the square root of 1 minus f of x squared. And then I can use this now to differentiate sine inverse of any function of x. Let's look at an example. Let's say I want to differentiate, find d dx of sine inverse x squared plus 3. Alright, so here we have d dx, or the derivative of sine inverse x squared plus 3. It's going to be equal to 1 over the square root of 1 minus f of x squared, so this part here squared, times the derivative of x squared plus 3, that's 2x. So that gives me 2x over alright, and I would take this a little bit further. Since this is just a square, I can expand it. So that's going to give me x to the 4 plus 6x squared plus 9. Which gives me 2x over the square root of, the 1 is going to subtract the 9, that's going to give me negative 8, minus x to the 4 minus 6x squared.